Hello everyone, this is Aditya Ajmera, and in this video we are going to discuss a very important topic from the geomorphology, that is the surface configuration of Earth. So we will understand how various landforms get evolved, get configured on the surface of the Earth. Primarily when we discuss the structure of the Earth, we take two dimensions. The first dimension is the interior of the Earth, and in this we try to understand various layerings of the interior of Earth and various boundaries between these layers, and also the material composition of the interior of Earth. And by all that we can conclude that the topmost layer is the lithosphere, and then the asthenosphere, also called the upper mantle, and then lower mantle, then outer crust and the inner crust. So these are all the topics we try to understand when we discuss the interior of Earth. But this is the surface configuration of Earth, in which we will understand what lies above the surface of Earth. We will discuss how the continents and the oceans get configured, get arranged on the surface of Earth. So this topic of surface configuration of Earth was in discussion from the earlier times, and it was before 1850s. All the scientists and the geographer and the people believe that whatever lies on the surface of Earth was as it is, get never changed from the evolution of Earth. That means from the beginning of the Earth and till the 1850s, whatever landform we see at that time was never changed, get never evolved. And this concept was known as the theory of permanency. So whatever landform we see at that time was permanent and never get changed, never evolved. But this concept, this theory was challenged in the early 20th century, and in 1912 he was the Alfred Wegener. Alfred Wegener challenged this theory of permanency, and he introduced a new concept, a new theory called continental drift theory. Continental drift theory. So according to Alfred Wegener, he gave two concepts. The first is the supercontinent, and the second is Sial and Sima. So Alfred Wegener talked about the supercontinents. He said that around 250 million years ago, there were a large giant continent. So all the continents we see on the surface of the Earth today were all combined, joined before around 250 million years ago, and this giant continent was known as Pangaea. And from the time this 250 million years ago, this Pangaea gets disintegrated, it gets separated into various pieces, and these pieces, these small parts of this giant continents drifted and arranged in such a manner that we see today the various continents on the surface of the Earth. So this concept was introduced by the Alfred Wegener, and he proposed that continents are not static, they are dynamic, they are drifting. And because they are drifting, this is why this theory is known as continental drift theory. But there were some limitation in this theory, and because of this limitation, a new concept, a new theory was introduced in 1962. So the Alfred Wegener was not logically able to explain why these continents are drifting, and a new theory was proposed by Harry Hess. And he proposed the seafloor spreading theory. So Harry Hess was basically a marine geologist, that's why he has more focus on the marine area. And he explained that seafloor is spreading, and because seafloor is spreading, the continental crust is also moving, is getting drift. So this theory was proposed by the Harry Hess, but it was also not able to explain why this drifting is happening, why the ocean floor is spreading. And to cover these limitations, a new theory was introduced in 1967, and it was the theory called mantle plume, introduced by Trudeau Wilson. He proposed that the uppermost layer of the earth is known as the crust, and below that a big layer, a giant space inside the earth, which is in the semi-solid state, called the mantle. So in mantle there is a large source of radioactive thermal elements, and when, because of the radioactivity, the semi-solid state of this mantle, the material get heated and the material rise up toward the earth crust, earth surface. And when the material get cooled, it is getting sink toward the core. So again it heat up, and then again it cool down. So this form a circular motion, a gyre-like motion, and this phenomenon is known as the convectional current. So this was the theory proposed by Trudeau Wilson. The mantle plume was proposed by Trudeau Wilson, and later it evolved into convectional current. Convectional current theory, which was given by Arthur Holmes. But all these theories were not able to fully explain, scientifically and logically explain how the continents are moving. And to fill this gap, a new theory, which was the most scientifically valid theory, called as the plate tectonics. Plate tectonics, which was introduced by Jason Morgan. Jason Morgan introduced the plate tectonic theory, and basically this plate tectonic theory was subsumed all the previous theories which try to explain the continental drifting. So the plate tectonic theory was introduced, and all the concepts, major concepts of these previous theories was subsumed by the plate tectonic theory. Like in this theory, the mantle plume, the circular motion called the convectional current of this material inside the mantle layer, it put pressure on the lithosphere. So according to Jason Morgan, the outer layer is known as lithosphere, and this lithosphere put under pressure because of the convectional current inside the mantle layer, and this make the motion of these plates. So when the plates get separated, it break into various parts. The parts of this lithosphere are known as plates, and the movement of these plates is known as tectonics. This is why this theory is known as plate tectonic theory. So later this plate tectonic theory tried to explain the movement of the plates, what are the different kind of plate boundaries exist. So when two plates move away from each other, this make a large gap, and when the molten magma rise up and fill the gap, this create new crust, and this is known as the divergent boundary or the constructive boundary. So we will understand these boundaries. So let us suppose this is lithosphere, and these parts of the lithosphere are known as plates. So because of the mantle plume, the convectional current of the materials inside the mantle layer, the plates will feel the pressure and move away from each other or toward from each other. So the shear stress force between these two layers make the movement of these plates, and in this case here we can see that the motion of the gyre is toward making away from each other, and this create pressure on the plates and it try to move away. So there here a gap will create, and when molten magma will rise up, this make the magma cool down and this create a new crust, and this is known as divergent boundary. Because two plates are diverged from each other and also called the constructive boundary. And when two plates move toward each other, because of the shear stress force created by the lower layer called the mantle, here you can see that two gyres are moving toward each other, and this creates the force on the plates, and this plate will get motion in which they will move toward each other, and this will create the destruction of two plates. And here you can see various volcanic activities. Large volcanoes present in the constructive boundary, and this creates the destruction of plates. This is why this is known as destructive boundary. Also called the convergent boundary. Convergent because two plates are converging toward each other. So these are the two type of boundaries, and there is another one kind of boundary which is called as transverse boundary, in which two plates are moving parallel to each other. Neither a new crust is forming nor a destruction of the plates is happening. So two plates are simply moving parallel to each other, and this is known as transverse boundary. So we have discussed three kind of boundaries: this constructive boundary or the divergent boundary, and the convergent boundary and transverse boundary. So these are the three kind of boundaries, and all the landform which are evolved on the surface of the earth can be explained by this phenomena, these three kind of boundaries. Like if we take the formation of Himalayas, the Indian plate is moving toward the Eurasian plate, and this is Indian plate. When it moves toward the Eurasian plate, it forms a convergent boundary. When two plates are moving toward each other, it forms convergent boundary, and this make a fold mountains. So two plates moving, this create folds, and this make fold mountains, which now called the Himalayas. So when India joined the Eurasian plate around 70 to 40 million years ago, this created the formation of Himalayas, and this is why Himalayas are arranged from east to west direction. And same like if we take the example of North America. In the North American continent, So this North American plate and the motion of the Pacific plate. So when Pacific plate get converged toward the North American plate, it form a fold mountains, and this create the formation of Rocky Mountain, which is arranged from the north to south direction. So this is how the plate tectonics can explain various landforms which are evolved on the surface of Earth. So we have discussed the surface configuration of Earth. We have discussed various theories, how the theories get evolved from the continental drift theory of Alfred Wegener to the plate tectonic theory of Jason Morgan, and also how the different plates, motion of the different plate create various landform on the surface.